Hi everyone, so today I will be showing you guys how to integrate with limits, and you will be doing a limit towards infinity for this function. And here are the 8 steps for integration. And the first step is to find delta x, which equals b minus a over n. And then you need to find xi, which equals a plus delta x times I. And then you need to write the whole thing as a limit with a summation. And then you need to plug in xi for every time that there is an x in the equation, and then multiply the whole thing by delta x. And then you just need to keep simplifying until you can't simplify any further, and then start plugging in the I values I will show you in a few moments. And then you need to simplify even more. And then finally, you can start finding the limit towards infinity. And here are the various I values that we will need, and you will need to memorize these for further use. And it includes I squared, and also I cubed. And these will be very useful for tests or quizzes. And now going on to the actual function, we can start with finding delta x. And delta x equals 3 minus 0 over n, which then equals 3 over n. And as you can see, this is the same b minus a form as I explained before. And then so you get 3 over n. And then now for finding xi, you do 0 plus 3i over n. And it's 0 because a equals 0 in our case. And then so you end up with 3i over n. And then now we can start writing the whole thing as a actual limit. So you can do limit n to infinity, and then we have to write the summation of n on top, and then I equals 1 at the very end. And after this, we can start by plugging in xi for every time that there is an x, because that is what we need to do in order to find the limit accordingly. So you do 3i over n plus 4 times 3i over n squared. And as you can see, this is just the 3i over n for every time that there is an x. And then we need to multiply the whole thing by 3 over n, because that is what delta x is. And now we just need to keep simplifying the problem. And we have the limit of n towards infinity like before. And we can now move the 3 over n to the very beginning, because we do not have to worry about that until the very end. So for now, we can just keep it there in front of the summation. So we have to continue writing the summation, and then 3 over n times I plus 4 times 9i squared over n squared. And this is just a more simplified version of the previous part of the function. And now we can continue to simplify even more and actually start finding the summation. So we do the limit of n to infinity, and keep the 3 over n at the very beginning, as I said before, and 3 over n times n plus 1 over 2. And this is just the I value that I showed you before. And now we can continue with the rest of the function. So it's 36 over n squared times n plus 1 times 2n plus 1 over 6. And this is the I squared value that I showed before, that you guys will need to memorize in order to do these types of questions this way. And now we can continue. And we don't have to write the summation anymore, because we've already done that by plugging in the I values. So you continue with the limit of n towards infinity, 3 over n times 3 times n plus 1 over 2. And you can see this simplified because the two n's on the 3 over n and the I value, they cancel out. So you get that, and then also the 36 and the 6 cancel out with a 6 on top, so you get a 6 times the simplified version of the I squared values numerator. And this simplified version just makes it easier to work with because it's more simplified, and this all over n squared. And now we can just keep writing the limit towards infinity and still keeping the 3 over n at the very beginning. And we can now multiply the 3 into the n plus 1, so we get 3n plus 3 over 2. And then we can multiply the 6 into the various numbers in the parentheses, and so we get that over n squared. And then we can keep simplifying and still keep the limit n towards infinity at the very beginning, and then also the delta x at the very beginning. And now we can split these two parts of the function into even smaller parts, even smaller individual fractions or numbers, so it's easier to work with. So you get 3n over 2 plus 3 over 2 plus 12n plus 18 plus 6 over n. And this just makes it easier to work with and to multiply the delta x into. And now we don't need to write the limit towards infinity anymore because that's what we are doing right now. So we can combine the step of multiplying and also doing the limit at the same time. So you get n over 2 plus n over 2n plus 36 plus 54 over n plus 18 over n squared. And every time that there is a n in the denominator for limits of infinity, that means it automatically will go to 0 because it means that you are dividing by an extremely, extremely large number, the largest number that you can think of that is possible or impossible in a sense. And this means that it is approaching 0. So you are just left with n over 2 plus 36, and n over 2 equals 4.5, and then so it's 4.5 plus 36, which equals 40.5.